Hey, this is Alex Head, founder of Subtext Radio.
This is Subtext.
Please go ahead and click the like button and the subscribe button. It really helps us to reach new audiences and promote the artists that we work with. Hit like and hit subscribe.
Okay, hi everyone. I'm Lyng and
I'm Anna.
And then today we also have Anders here with us, our guest researcher. So today we are going to talk about KAIT by Ishigami, that's built in 2008. So maybe we explain a bit more about this series. So this is from inspired by our kind of spiritual professor. He didn't teach us directly, but some of his lectures influenced us. So it's him thinking about 10 buildings that define, like for you think about the whole history of architecture and you try to select 10 important architectural projects that is important to you, that you think has defined the history of architecture, right? So in this spirit, this is my own list. This is in 2020. Now it's a different list. So the list kind of keep changing, but it keeps you thinking or focus on what at the moment you are thinking about and why these 10 buildings are important for you to define your own work. So and then me and Anna sort of came together and we thought of taking each one of this building and we will do a very deep dive, thorough research and a close reading on this building, right? So we're going to talk about one building per hour. The first one we did is Einstein's Tomb by Lebbeus Woods, and that's a year ago. So 1 year later, we are a bit slow.
It's a slow project. Yeah.
Hopefully we can speed up. So KAIT is on this list because it's a project of new beginning. So they start new thoughts or trajectories in architecture rather than it being a very refined, perfectly detailed project. And the second reason is because this is the first time, at least to me, that I see parametricism being applied to space, not just the form. We'll go more into this later. Okay? So with that, Anna's going to do a short intro on the building and then we'll go into the analysis.
Yeah. So as Lyng mentioned, this is an early project by Junya Ishigami. Just say a few words about him. So he was born in Kanagawa, where this building that we're going to talk about is sited actually in 1974. So then he studied in Tokyo, and he also worked for Kazuyo Sejima at Sana for about 4 years, from I think 2000 to 2004. So this project was started, the KAIT project was started in 2004, basically just after he had finished working in that office, and was one of his earliest projects. So it's really
This
sort
is
of fascinating.
second
Finished project. But it's happening at the same time as a few others, I think, too.
Yeah. So the first project is the famous the table, the big slim table, and this is like the first building that is building.
Mm-hmm. And now since then, Ishigami has like several other really key projects and has been teaching at like Harvard, Princeton, and as we were just talking about, also in Mendrisio in Switzerland. This project is for a university in Kanazawa. No, not Kanazawa.
Kanagawa.
In Kanagawa. Yeah, sorry. And basically the idea for this building from the university was that they needed a space for students to do their own independent projects, specifically like things that they make, like carpentry, ceramics, but also like planes, airplanes that are human powered. And then it should also be open to the public for young people on the holidays and things, for people to do workshops. So a total mix between programs for one person or two people or groups. And the building itself is 2,000 square meters. And it's basically one room, and you can always see the entirety of the whole space all the time, because it's only held up by columns. There are no walls in this building. So 405 columns with only 305 that are structural. And the height, Lyng wrote this in here, increased from 3 meters originally during the design to 4.8 during the design stage, I guess, to also allow for this like extent of the perception of the 2,000 square meters of space. So you can see we're looking at a plan right now. It's basically a square with 3 entrances and dots of random looking columns spaced out throughout this kind of trapezoidal / square space with a glass curtain wall around the edge. Should we look at the next? Yeah. So this is the site plan to the left of this image, where you can see that the KAIT building, so it's spelled KAIT, from Ishigami, is kind of in the center of this campus. And since then, there's also been built another KAIT building to the east of it, also by Ishigami. We're not going to talk about that one today, but it's also a fascinating development. And the building's just kind of surrounded by other campus buildings, and is kind of a block of its own. So there's streets around the perimeter of this building looking at other buildings and courtyard or plazas and another student center. And on the right of this image, we've got a model. We'll be talking more about how this building was designed, but it went through a lot of different iterations to speculate on how these columns might form ambiguous boundaries between different types of space, be they for individuals, pairs, or small groups, or large groups of people. Here's the roof plan and the section and the larger scale section, where we begin to see already in the way that Ishigami is portraying this, that there's a relationship between the building and a type of nature or forest, because he's showing in the larger section the different directionalities of the columns, and the very thin long columns and some trees behind the space. Yeah.
Okay. So he's really interested in building natural spaces, but not replicating nature. So there's a different and we're going to talk about how he tried to make all the rules imperceptible, right? So there's no algorithm or rules. In this drawing, he's likening the columns to a forest, right? So this on the right is just an image of a forest of timber bamboo, right? And then he's comparing it to his own plan. So the way he designed this building is through a lot of physical modeling. And I think halfway through the design process, when he started sending all these plans to the engineer actually wrote a program for him, right? So that they can tweak the column and instantly calculate. So this is the engineer. So this is the program here. So you can see how they can shift the column and instantly they will calculate all the structural loading of the building, right? So to make sure that he can shift the column, but it's still stable. And at the bottom, what you see is a perspective of the columns, right? So this building is actually not designed by a set of rules, like conceptually, abstractly more. And it's actually designed based on perspectives. So the way he worked is, in the beginning, he wasn't quite sure how the columns would feel like. So they actually started with a 1:1 scale model, right? So after doing that, they kind of know how once the space feels like and how tweaking some of these columns feel like. Then they went on to make 1:20 and 1:50 columns. So 1:20 is they would build part of the model, and then 1:3 smaller zoom in spaces of the model. And then when the computer program came in, they were quite familiar with the feel of the spaces, and then they could go down to 1:50, right? So they were constantly concurrently like using scale model to make design. Okay, so these are so if you move forward, so these are like on the right, these are like the computer structure analysis, and then on the left, they would build the physical model, and they will make notations of where to move, shift this column, how do you read different cluster of columns, and then what are the spaces that they can use for, right? So they just keep going back and forth, but in a way, it wasn't kind of like determined by, density abstractly. So everything is amazing that is based on perspectives, but perspectives in this kind of situation is endless, right? So from he's also very vague in a lot of the description. So like for the you can see here, so we are not quite sure what are the reasons for determining or changing some of these columns. So you can
Yeah. Can I interrupt?
Yeah.
I think, like, for me, it's also important maybe to point out as part of the presentation that Ishigami actually did start off with the idea of a space purely made of columns, a free, flexible space. But his original conception was a regular one, so it was a 4-meter grid, and he wanted to try very subtly shifting the direction of these columns in order to create subtle changes in how we perceive the depth of the space. So he started off with the idea of like the view between the columns, and then as the program became more determined and conversations developed, then the columns also started to move, and the space became more sculpted through these iterations of processes. And that's why now it's not a grid, but instead something that looks random, but is in fact a very strong intention of the collaborators to make, a totally new space, right?
Yep. So here you can see on top, these are the models built. So this is probably maybe 1:50 or 1:20 kind of model. And the final building in a context, so they are surrounded by more typical conventional school buildings, right? So he writes about architecture being a new kind of environment that is neither natural or artificial. So he's talking about, for example, in the natural environment, you have forest, river, sea, and rain, and nature spaces like that you cannot find in architecture, right? So in architecture, then it's like man-made, and he's trying to make a new kind of natural architecture with a new kind of natural environment, but not really trying to replicate forests or mountains or river. Does it make sense?
Mm. And this piece of text that we're showing here is a longer essay called Freeness in Architecture, which is a kind of manifesto that Ishigami wrote around fundamentals of architecture and his interest to formulate like new and unknown relationships between architecture and society. So for me, what's really interesting about that manifesto is that he's listed out several tools or goals like freeness from the existing environment, what we're showing here, which is number 4, but also freeness from scale, freeness from form, freeness from existing architecture. And each of those things in themselves is not actually the concept of the building, or in fact, what happens, it's like once you try to free yourself from those things, then something else unexpected could happen, which is what's new. So rather than trying to define what's new, he ends up defining ways and paths to get to something new. And in particular, related to this idea of like free from existing environment, I think what came out for me was that he starts to break down the relationship of like nature and artificial, that they influence each other mutually, and that the role of the architect is no longer just to like shelter people from the environment or from nature, to displace people from the world in which they live into something that's safe, but instead to connect people between the natural and the artificial. And that's like, I think in itself, something that constantly is negotiated in architecture, but to point out and say like, I'm no longer that interested in sheltering. Like you can also see it in some of his later projects where he draws the wall of a house, but then doesn't put a roof on it. Because there's a garden, then that becomes part of the interior environment. And similarly, in this project, there's something about sort of conceiving the space as if it's like, here he writes, I try to think about spaces that are conceived by the natural environment, such as fields and forests. So it's through the thinking of a natural environment that you come to a design, and you get connected into being part of a sort of natural space.
And this is his writing in JA. So he's purposefully not trying to design a building based on algorithms or strict kind of geometrical rules. So it's a lot based on intuition, I guess, and perspectives and intuition, right? So if you try to find like to script and find an algorithm that can define all the shapes and direction of the columns, you are not going to find that, right? Because everything is done through physical modeling, right? Based on perspectives. The next thing we're going to talk about is ambiguity and how we see fluctuations in this building rather than extremes. And also whether this building becomes homogeneous or you have very special local environment, right? So he continued to compare this building with forest, and this is the drawing of all the different species of the trees that he put in his book next to the columns, right? So you just look at all these trees, right? They are actually one species of trees, right? So coming from a tropical country where we have rainforest, right? This is extremely strange to me, because it's like, oh, this is really a plantation. This is not forest as we know, right? So, and then there's another image, and this is, I don't know, bamboo or something. And then on the left, you see, this is a photo of his model again. And you will see that, in this view, we only see very slender columns, right? Like really like the bamboo trees on the right. And then another tree or plantation to me that, he's using And out of this, there's only one image. Wow, okay, this forest is a bit more familiar to me, right? So you start to have thicker trunks and then thinner trunks, right? But in his building, so this is the image. But in his building, the variation is really not that much. And until a few weeks ago, Anna sent me a video of how Japan was growing this forest, cedar or cypress forest, right? Sugi is sugi tree. So they use this to build temples and all the timber buildings in Japan. And to make sure that it's sustainable, they would harvest, they will grow. So and harvest in a cyclical manner, right? So actually this kind of secondary forest is very common in Japan, and this is one that's found in Osaka. And I guess in his image, when he refers to forest, he's really not talking about tropical rainforest or Amazon rainforest, right? But rather forest that's like that, right? So the spectrum of species, there's maybe one species, and then but the difference in sizes is not really that great. And so this is the section that you saw earlier, and then kind of behind you see the real trees, right? So he drew this section, and on the right, this is the image of the building, right? So later we'll talk about the envelope, but we feel this envelope is kind of harsh.
Yeah, he writes in his books also about sort of the accessibility of the abstractness that he wants to bring to people that come into this space. So I think understanding that it's like a forest is sort of just a very accessible way for people to come in and start to make sense of what it is that they're encountering, and then still appreciate the building as a building, and then the abstractness allows him to create a language in which anything else can happen. So he also has these furnitures like the tables and chairs and also plant pots, and then all of the students coming in and the things that they bring in that also look really wacky and different. And so the abstractness that he presents or like brings in as like the foundation then allows for a lot of change to occur within it. So there's a lot of ambiguity within the actions of the interpretation without ever requiring the architecture itself to change, which is for me like has always been the critique that I took on about parametricism, or like the problem that I saw with parametricism that is unresolvable, is a little bit like a building can take on parameters that have changing aspects, but then it doesn't, once it's built, it doesn't continue to change. This building actually kind of pushes that criticism of parametricism due to the constant new interpretations by the people going through it, because of the way that the columns work. So one interesting thing that he also mentions is like normally in a building you have point A and you have point B, origin and a terminus for where a wall starts and ends, and then the wall goes up in between these 2 points, and then you can't see any further. And in this building there are all of these points, but there aren't walls between them, and so the thing that you can't see isn't there, but you have all of these suggestions of spaces that could have boundaries, and the person that's in that space is always left to question for themselves whether they're meant to go through some columns or whether the columns are actually connected to each other.
Yeah, so here we are going to look at the occupation of the spaces, and this drawing is actually a survey drawing, so it's not how they planned for the building to be used, right? But this is like survey on July 15, 2010, right? And then he's comparing this to the canopy of the forest, of the trees, and these trees are like occupying spaces light and air, right? The same way as on this building. This is the planned version, like one of the version that they imagine how the space will be used.
Mm.
So they also have here you can see the kind of zoom in version where you start to see that the columns are acting like a wall because these two human, they're sitting against these columns and just enjoying the width of it rather than the thinness of the columns, right? So they drew a couple of scenarios. I think on the right you will find the extreme sizes of the columns, right? The really flat and long ones to the ones that are more squares, right? Defining the spaces. And look at the photos, right? So whether we'll go into structure, so you see some columns on the edge and some really flat.
And notice the airplanes. So there's one in the foreground there, and then there was also one in the background of that image hanging in the space. They're white, almost the same white as the columns that are throughout the space and the ceiling. So they begin to like blend in with the space at the same time as being a sort of absurd possibility of something so totally different than a building. It's like some humongous birds inside of this forest.
And the reason why they raised the height from 3 meters to 4.8 is because when he was studying like the perspective, right? So imagine this is 4.8 and 3 meters is probably somewhere here. So it wasn't tall enough for them to feel the columns. Like you feel the roof immediately. So after making the big large scale physical model, he decided to raise the roof by 1.8 meters. So again, it's a perspectival decision, and not kind of like a overall planning, abstract kind of decision.
I think this picture is really interesting to see just how like not only you see the whole 2,000 square meters, but you're also connected to the outside of the building because of the glass facade all the way around. So you're always seeing past the forest out into the beyond. And each time you turn around in the building, I mean, it's very difficult to show just in photographs, but you can go into Google Street View, or some of you might eventually visit the building and turn it through the space. Every single movement of the head and of the eyes changes just how much of the thickness of the columns you would see, and the building kind of kaleidoscopically opens and closes as you turn within it to create like different types of depth.
I think it would be interesting if the trees are not in a surrounding. They are not this kind of trees, but the trees that he showed in
his sketches.
Then you are kind of confused, right? The artificial and the real trees. Yeah. So this is the first point of his manifesto, where thinking about architecture being free from uniform functions. So one of that's something that, and so not tied to function, which means you don't start designing a building based on function. You don't know what they are, and keeping this ambiguity of program and occupation of the architecture.
So like if you do think about a forest, it doesn't tell you what to do there, but at the same time, going into it by seeing like a clearing or a density of trees, you might decide to behave differently in one space or another. And another thing that Ishigami talks about is just the complexity of the systems that we live in today and the speed at which everything is changing, the amount of like digital change that we're kind of constantly being surrounded by, and that there's like infinitely different kinds of values going on, and that the only way to create a new architecture would be to like capture some of this richness between what is like a place where you don't try to control those things, basically. Don't try to control the function and don't try to control people's use of one space or another.
So here you have the structural drawing by the engineer. So actually there are 305 structural columns. And there are two types of columns. The red color on the bottom left, these are called compression columns, and they take the load of the roof structure. And the blue columns, they take lateral load, like wind load, and earthquake load. Okay, so traditionally in structure, in order to take lateral load, you will have shear walls, and these are very long concrete walls that is so going in the direction of the wind, right? So you will see this usually in the center of the building next to the lift core, or part of the acting as part of the lift core. Okay, so you can see how then the red columns, they are kind of evenly distributed throughout the whole space because they have to take the load of the roof. So they are slightly deviated from the grid, but not much, right? So in a certain area, you still will find one column, right? Whereas the blue ones, they are a bit more free to be distributed randomly, as long as the sum of the lateral loads add up to be 0. Okay, so like one is taking this direction and this. So as long as they add up, and that has to do with the orientation of the columns. Okay, so so this is very rare and atypical of a building. So especially, if you refer to domino house, the traditional slab and column system. Okay, so to have two types of columns and each taking a different types of load. And so here on the right is what they are doing is they have the vertical column, the column that's taking the vertical load. So it's under compression because the roof load together with the snow load is kind of pushing down on the column. So there's a footing, it's connected to the ground, right? So in order for this column not to be engaged in any lateral loading capacity, the joint to the roof beam has to be a pin joint, which means it's free to kind of move laterally, right? So this column will not be, if it's a fixed joint, then it will start to bend, right, vertically. And then the tension columns, right, on the other hand, what they do is they are taking wind load and earthquake load, which is horizontal load. So in order to do this, they have to pre-tension the load. What does it mean? It means they first dig a little hole in the ground so that this column is inserted, can slot into the ground a little bit, and they would load the roof with the snow load, right? So they added some weight to simulate the snow in the winter. So that's the extra load, right? And this vertical tension column is actually welded to the beam above, right? So it's kind of above, and then once they do that, they take off the snow load, right? So the whole roof is going to be, instead of bending, it goes back straight, right? So this column kind of
bounces back up.
Yeah, bounces, yeah, right? So this is the two types of columns that you have here, and you can see on the left, this is the diagram that is trying to explain this, what I just explained here. Okay, if you have question, you can just ask. Okay, so this is a detail of the joint. So the top, that's a compression column, so it's kind of welded, how it's joined to the ground, right? At the bottom, you have the tension columns, and showing how it's being welded on top to the beam. So this image, what you are seeing here is on left, bottom left, you see the white color structure. That's the roof structure. And the red color bars, those are the loading bars that is simulating the extra snow load in the winter, right? And then so in the photo on top, you have all these holes. So these are all the excavation required for the two types of foundation. Okay, so and so you have here 305. Actually, if you look at this whole diagram, there are 306 columns. So it's, but he says like 305. So there's one extra one, which I don't know what it is. Okay, and this is all the variations. And of course, we try to find the limits of this spectrum. So the vertical loading columns, their proportion is a little bit more squarish. So the width kind of varies from 55 to 62, and the vertical is 80 to 90. Right? Those taking horizontal load, they need to be a bit longer because it's like shear walls, right? So you want to prevent the load from bending this way, right? They are not taking vertical load. And this is the variation from 16 to 45 and 96 to 160. Yeah. So on the right, you can find, I've circled two. So the red color is like, that's the extreme, the smallest column. And then on the right, the blue color, the circled one, that's the flattest and longest columns. So he drew probably this segment of the plan because he's trying to capture the extreme spatial condition of these two columns. Right, so this is a photo of the columns. So now if you look at this photo again, you can identify which are the ones that are that's taking vertical load, right? So you can see here, you see this guy here. This is the one that's taking vertical load because of the proportion, right? This guy is also red. And then this will be the ones taking the horizontal load because it's longer. Okay, so the other thing that he tries to do is he doesn't want people to feel that, to know that there's this difference.
Lyng, you've just ruined the building.
This is the
yeah, because now everyone in this call knows
they know so
the secrets of the building.
So he wants everything to stay ambiguous, and so he hides the detailing. He made the two detailing the same, although one is pin joint and one is welding. But now if you look at this photo and like more photo later, let me see. Right, you can see that we can no longer tell, like this is a compression column, but it looks like it's welded because that's what he tried to do on purpose. Oops, what happened? Oops, sorry. Yep. Okay, so now you cannot unsee. When you go, you're gonna know, oh, this is a compression column and this is a
Yeah, I mean, I think there is something beautiful about the desire to, and I think it's mysterious to see the building and walk into it, and most people wouldn't know why. What's the mystery? Like, of course, there's no walls, but structurally, there's a mystery beyond that we are confronted with on like an everyday basis, which is that there are reasons why there are walls, and how could you possibly design a building that gets away from it is quite difficult to imagine. Getting away from the shear wall typical answer. And like that's part of one of his manifesto ideas, is like freeness from existing architecture, in which he says, like pretty much use any means possible, like use particle physics if you need to like conceptualize your space. Don't limit yourself with the like standards of construction.
Yeah. I just noticed like the furniture in this photo, like this is you see, it's so thin, these chairs and table, that they need extra steel member to kind of strengthen it before, if not, it's going to bend a lot. And that's exactly what it was, right, for his first project, his table. The table is so long, but it's so thin. And how he did it, right, by kind of pre-tensioning the table. Okay. So here, yeah, so in this photo now, you can see, right, so some of those that's really thin, these are the horizontal columns, right? And now if you look at the section again, you are going to see that the top one on the left, can you see my pointer?
Yeah.
Yeah, this one is the compression column that is taking the vertical load. And then this footing, these are for the tension columns. Okay, so you can start to read this. And
Okay, so we'll make like a short attempt to bring in like my own attempt to understand this building through the plan. So I wanted to kind of make a drawing of this building to see what I could find in it. Lyng and I had been talking about the density of the columns and how we felt like it's still quite homogeneous. Like you could be even more radical about the placement of these columns, or there just seemed like also this statements by Ishigami that he tried to make entrance-like spaces or office-like spaces by putting the columns where they were. So I wanted to try to make a drawing and also to understand the edge condition of this building, which we've said is glass, but it's also like reinforced at very regular intervals, probably just over a meter apart. There are these structural glass members along the entire flat boundary. So I started making this drawing on the plan, which in the next slide, you can see I just went about like circling every single column so that it became like more visible in the plan, because there's such tiny dots. They almost don't feel like they could even begin to have an effect on the space. So I wanted to kind of enlarge them and give myself a better understanding of how these spaces created larger or smaller spaces. And then to kind of defy Ishigami, I started to connect any of the columns that were closer together than like the spacing of the edge condition. So anything that was about a meter apart, I drew like oblong lines around and started creating these kind of like, I don't know if, to me, they almost look like cells or like plant cells. And then going from there, trying to understand, okay, if from that set I had to continue to create borders or boundaries, what sort of spaces would emerge? And this is the very strange plan that came out of tracing Ishigami's work, which almost looks like, I don't know, like geographic or like topographic spaces, but very irregular archaeological findings. And then I overlapped that with the way that the building was used from this drawing that we showed previously of the survey of the building, and how the furniture was actually placed by the users once it was in there. And it was a bit like eye-opening that no matter what I would do in the plan, the use case, like without looking at how people put the furniture, it never seemed to actually correlate. Like the plan interpretation is not the same as the like firsthand perceptual interpretation. So if you go to the next slide, I said, okay, well, I'll take back out those walls and add the boundary, because I think even though we'll talk a little bit more about the edge condition on this project, this boundary is, as on the walls as well as on the roof, kind of is questionable as far as like how the space is conceived. Like, is it actually a boundary because it's so regular, because it's doesn't seem to have its own set of like natural logic. Instead, it's got some sort of geometric logic that one would expect from a totally different building. If you go to the last plan, Sailing. In any case, what I think I just came away from this thinking that this building is unlikely to be understood by plan analysis, but as with most plan analysis or any architectural analysis project, what you get is maybe a new building rather than the same building when you start drawing the things and start making sort of discoveries and uncover the way a building can be conceptualized through that process.
So if we talk, so sometimes he talks about this building, he compares it with the forest, right? But sometimes he compares it with stars and galaxy. And then this is he's comparing the CCTV of the users of the buildings with like birds, right? So really it doesn't quite matter what kind of natural system he's comparing to, right? So in his mind, like he doesn't have to just follow one, but how he can use a few, when he, like some of the spaces, they are linked together like stars, right? So that forms a zone. So he's quite free in the way he refers to, all this kind of natural systems. And this kind of tradition of referencing to nature in architecture is quite common in Japan, or it's a pursuit of also Sana and Nishizawa. Like they talk about architecture being a landscape and why they do, all the slopes and like Rolex and certain buildings, they try to actually be closer to nature rather than, the traditional division of this is natural and this is a building, right? So this is Nishizawa writing about how when he went to visit Parthenon, he's quite surprised that Parthenon is conceived on top of the rock crop like a landscape. Like Parthenon is part of the landscape. Parthenon is not actually sitting on top of the hill. So that's something that I don't know, or maybe it's him reading the Greek architecture, right? So that's the pursuit for a lot of Japanese architects. And this tradition of abstraction is also something in the Japanese culture. Because if you look at this yayoi, so one of the two traditional tribes from Japan, so yayoi's sculptures, they didn't start with very realistic sculpture. So in AD 200, they were already making very abstract sculptures of dancers. So the maybe unlike also our own culture, I think we are a bit more realistic. The Japanese really they are quite abstract. So you look at Ranji, the Japanese garden, right? So they would kind of abstract the landscape in rocks and sand. They are not actually remaking the forest, right, or the natural landscape. And in the last part, I think we want to talk a little bit about this idea of the environment being an endless field, and this envelope, right? How he deals with the whole glass facade and the roof is actually kind of cut off of this endless field that he's created. So they are really after building an environment and not a form. So if you look at this building, you see the outside, the envelope is actually very clean, but the inside it feels like a forest, and you would get lost inside, right? But from the outside, there's nothing much to look at. You just have a very clean, standard kind of glass facade. So it's a little bit different from the first part of parametric design, where a lot of buildings, they look very parametric from the outside, but the inside is essentially Kobu's domino house, right, where you have slabs and columns, right? So this is something that you perceive from the outside. It's a very dynamic form, but if you experience the space, inside is quite predictable. So I think in KAIT, he actually did it the other way, which is the reason why he's on my list. And I think it's a kind of new way to apply the techniques of parametricism. So again, this idea of endless fields is actually from it started with Toyo Ito. So Ishigami worked for Sana, and then Sana worked for Toyo Ito, right? So they are interested in creating really a very dynamic internal structure, which is spaces, but the boundary of it is like almost like a pure box, right? That just cuts off the facade. So it's a little bit like Kobu's facade, where he has the column grids that extends forever, and then it's just kind of cut off by the elevation. So the inversion of this application of parametric design, right? So we're not going after form, but they're going after an endless view of environment, and the box is the cutoff. Okay. And again, this we can trace back to the kind of culture of Japan, where they draw this kind of exonometric scroll, the endless scroll of spaces. So it's endless, right? These spaces like continues forever, right? So in one of the earliest Sana project, this is what they were trying to do for a museum, right? So the way you see they draw it is this. So it's just that this view is more rectilinear, but actually the whole lineage of Ito, Sana, and Ishigami, they are kind of after the same thing. And this is the building from this drawing. Yep.
So I wanted to bring up the Western, maybe one Western European reference that relates to the way that this building's been conceptualized somehow, and also to this idea of the endless fields, the sort of experimental architectures, so to say, of Constant Neuenhuis, called the New Babylon series, which you can see some sketches of like a sort of infrastructural space in which many different activities happening, like partially held up by tension cables and poles inserted into the ground, so a free floating kind of atmosphere. Constant was working out of the tradition, or out of the movement of the Situationist International, and started this project of New Babylon around 1959 and worked on it until 1974. And then you've got kind of a similar project by Cedric Price called the Fun Palace, which was developed together with the theater director Joan Littlewood, also 1959 to 1961, in which a set of trusses, huge infrastructural space is implemented into a landscape, and then onto which smaller buildings and circulation means can be hung into or built off of. So you have like a large vertical structure that's already there, and then individuals can go about creating freeform structures inside of that. And then the third reference is Yona Friedman's work. His entire life, he worked on a set of drawings and sculptures and installations that he called mobile architecture, which are similarly held up by a network of structure, and in which individuals can play and come up with their own ideas. So these three references are sometimes thought of as kind of like outside of other hegemonic ideas around power in representational architecture. Like you might find when you look back at architectural history, then you'll find museums and concert houses, housing blocks, and things like that. This set of ideas is actually more the idea that individuals can create their own spaces. And I see this as somehow related to Ishigami's approach in that, he wanted to remove the freeness, have a freeness from functions. So by doing that, he's asking the inhabitant to come in and do that work. And in the Western tradition or Western architectural ideas, this is kind of almost an anarchist approach because it's something that is skeptical of power, it's skeptical of hierarchy, and tries to support or nurture voluntary and free associations. So that's like when by choosing the idea of creating like a column structure that has no other walls and has no hierarchy, I feel like in this project Ishigami has like produced a new architecture similar to and actually built something that was being attempted to be proposed by several other architects of the 60s, and has a sort of political implication of this sort of free association without hierarchy. And just through his manifesto and looking for freeness, I kind of wonder what that would be. And at the same time, it's all very like formal approach. So in the next slide that we have, I just kind of have a rhetorical question about like, well, is this freedom, does it actually move into a political or social freedom by claiming all of these goals of freeness from scale, form, architecture, or the environment? Or could there also be like architectural and social freedoms that are pursued through feminist thinkers or intersectional thinkers or anti-racist thinkers like Jane Jacobs, Silvia Federici, Ina Pretorius, or Audre Lorde are some of the people that came to mind as I am thinking about, other ways to free architecture and move into new relationships between architecture and society. So this is, just a rhetorical question out there about which tools we use and what ends they might achieve. Sometimes we don't know, as I pointed out earlier, and it's about finding ways to transform the world without necessarily knowing where it will go. In that text, for me, like when I reread it yesterday, the thing that like really popped out about the freeness from existing scales is that he wants to move beyond the city. He wants to go beyond the idea of like the skyscraper or the building and into actually the extents of human awareness. So working with the phenomenological of like what it is we're able to perceive, like what a horizon is or what the limits of the sky are, change the relationship that we have to not only like each other, but also to what it is, what we are a part of. So the thing that I found really interesting about this idea of becoming free from existing scales is that a building might no longer just address its inhabitant or the city in which it exists, but it is even challenged to address its global relationships. So I think that in his buildings, he's beginning to approach like a global address with the buildings and also like a cross, to work across time. So working with the past of the sense of like the nostalgic past of nature, as well as the artificial reality of our present and our future, sort of collapsing time and working with like a nonlinear approach to time and space. The deeper you get into this, I think your mind would really have quite a big shift in a process of analysis or creation of something like that.
I just wonder like whether because they kind of move the furniture in and then it will start to become permanent, right? Or like with the airplane that's in the ceiling, right? It starts to be a bit more fixed and they cannot fluctuate so much, right? And whether they clear out occasionally so that you can reoccupy again in a completely different way.
All right. Do we have any other questions? Other comments? Anyone?
Nope.
No. Maybe we wrap it up.
Okay.
What do you think, Sailing? Do you
Sure.
have any concluding remarks?
No, unless.
Yeah,
All right.
it was nice to discuss with you guys. Thanks for everyone showing up.
Thank you. What? See you 1 year later for the third one.
Living with constant elevation through the sound waves of your radio station.